Welcome back to my channel. I hope you are all doing great. This is Shiva Prasad. Today we are going to solve one more Leetcode medium level problem, removing stars from string. The problem number is 2390. This problem stated as medium, however I feel the same. Let's try to understand the problem statement. You are given a string yes, which contains stars also. In one operation, you have to choose a star in yes and remove the closest to non-star character to its left, as well as the star itself. At the end, you need to return the string after all stars got removed. Okay, let's try to understand an example. So, lead code basically, but there are stars in between. So, performing the removals from left to right. So, the closest to character to the first star is T, right? This is the first star. The closest one is T. So X becomes LEE star COD star E because we remove the star and it's closest to left non-star element, right? Then the closest to star to the second star is E here. So we remove E followed by the star. Then S becomes LECOD star E. Then the third star is going to be this. The closest one is going to be D. We remove D and star. Then at the end we are going to get LECOE. Then there are no more stars and we return LECOE. I hope you got the problem statement. Let's go and see how we can solve this particular problem. So basically, this is what the given string, right? LEET star star COD star E, right? So this is the input. So the first and important approach is leveraging stack data structure. Okay, let's see how we can solve this problem using stack data structure. So basically, we are going to iterate through this complete string, each character I mean to say, and then we push whenever we encountered a non-star and we pop whenever we encountered a star. Let's see how it is. So assume this is my stack. Okay, this is my stack container. Okay, first L, is it a star? No. Then I'm inserted, I mean stack dot push. Then E, is it a star? No. Stack dot push. Again E, is it a star? No. Stack dot push. Then T, is it a star? No. Stack dot push. Great. Then star. Yes, it is star. Then stack dot pop of last element because we need to remove the closest left side non-star one, right? Then this is going to be popped up. Then you are going to have LEE only. Then again you come here star, the next one, right? Then you remove this also. Then your stack going to have a LE only, right? Then you come to this one, C. Is it a star? No. Then C got inserted. Then O got inserted. Then D got inserted. Then star. Is it a star? Yes. When it is a star, then D got removed. Okay. By the way, this last one is E, not C. So then I come to the last one. Is it a star? No. Then it got inserted. So now see how many got removed, how many got there. Yeah. So E is there, good. O is there, good. C is there, good. E is there, good. L is there. So your output is going to be LECOE. Okay. Is it what expected outcome for this string? LECOE. Yes. So we achieved it. So just we need to traverse through this particular stack and we need to, what I can say, derive the solution. Yeah. Before going to the next solution, let's quickly submit the one. So in order to save the time, I just taking my last submitted, which is on stack. So basically I created a stack of character and I iterated through each character in the string. And whenever I encountered a stack, I just did a pop. That means the last one got removed. Else I just pushed it. And at the end, I took a string builder because I need to form a string out of this stack. So I iterated through the stack. So then I appended the each character into this builder, string builder. Then at the end I returned. And you may get why this returns me in the right order because I'm not doing stack pop. Okay, so I'm just iterating. So basically, when you look into here, okay, it works on the iterator. If you would like to understand how this is possible to get the stack from bottom to top, then you have to go through and see how toString method works. Okay, so just leverage the stack data structure in detail. But at the end, yeah, it returns from bottom to top in this case. Now let's click a run. Yeah, it ran and submit. Yeah, it got submitted. Great. Right. Now let's understand what are the time and space complexities with this approach. Right. The space complexity in worst case, it is going to be big O of n, isn't it? The time complexity is going to be big O of n because you are going to iterate through the what I can say string only once. Okay, then you perform the constant operations push and pop. So this is the first approach. Now let's come to the second one. Second one is simple. We take some array and we play around with what I can say a constant variable. Okay, there is no particular data structure specifically I'm using apart from the array. That's a normal way of solving most of the problems. So let's see how we do in this direction. So basically what we are going to do here is we are going to convert our input into a character array. Okay, so in the sense like L, E, E, T, star, star, C, O, D, star, E. Okay, treat this as a character array. Then we are going to have a pointer called J equal to 0. Okay, so the ultimate goal with this approach is we are going to iterate through this one. Okay, whenever we encountered a non-star, okay, we increment the J. Whenever we encountered a star, we decrement. Let's see, don't get tensed. So first we start with this. Okay, assume this is ch character, sorry, array name. So I'm going to iterate through the input array as I said. So this is my input array, COD star E. Okay, so I'm at this position L and my initially J is 0. So I check whether L is a star or a non-star. It's a non-star. Then what I'm going to do? CH of J plus plus equal to what? This L. Okay, what happens? This remains the same. J becomes 1. Okay, at 0 index, L got inserted and J becomes 1. Then I come to second one, E. Is it a star? No. Then again I do the same operation. Then J becomes 2. Here it is going to be E. Again I come to here, E. Is it a star? No. Then J becomes 3 and E takes place here. Then T. Is it again star? No. Then J becomes 4 and T takes place here. So far it's good. Okay, now let's see the good case. Star. Is it a star? Yes, of course. Whenever you encountered this, decrement the J. What is the J currently? 4, right? So let's make it 3. Why I am doing? You have to decrement by 1. 3 in the sense. Why I am doing? You will understand. Let's see. Again star. Again decrement by 1. That is nothing but do. So what is the J current value? 2 now. Right? Then you come to here. Again non-star. Okay. So whenever you encounter non-star, you have to perform this operation, right? What is J? At the second index, what is E? Instead of E, C is going to be placed. Okay. J is incremented by 3. Isn't it? We are doing J plus. Then O. Okay. Then CH of J plus plus equal to L. J is what? 3. At the third index, okay, O will be placed and J will become 4. Then D. Yes, CH of J plus plus equals to. At fourth index, D will be placed. Okay. Then J will become 5. Isn't it? Then star. Whenever you encounter star, as you know, you need to decrement. Decrement in the sense this will become 4, right? Then you come to here. This is non-star. J plus plus equal to what is J? 4. So D will be replaced by E. Then J will become 5. Now, if you carefully observe, from 0 to whatever j, okay, between this range, okay, you are having your expected outcome, isn't it? That simple as it. So at the end, return what I can say content of this character array between 0 to j. J is currently pointing to 5. That means you have to come from 0, 1, 2, 3, 4, fourth index. That's it. You got your output. So at the end, you need to return your output. This is just another way. Okay. So what is the space complexity? The space complexity is still going to be big of n. The reason is like we are taking this character array. So assume there are no stars. Okay, in worst case, I'm saying then your character array going to be remain the same and you are going to return that. So you are utilizing the what I can say space of big of n, where n is the number of characters in the input array. What is the time complexity? It is big of n. Okay, we are doing not any operations apart from this constant operation. Okay, so that's all. Let's go and see how we can solve this one. So I'm going to take one of my recent submitted just 30 minutes back. So I just take the copy. This is I'm doing just to save some time for this video. Yeah. Anyhow, I will walk through. So now if you see, I took a J and then I converted this string array into character array. Then I started iterating through. So whenever I encountered a star, as I said, I decremented the J. Else, I just inserted that into the particular position character array. At the end, you see I given ch comma 0 comma j. That means it is going to return the values including, I mean, within this range from this input array, character array, I mean to say. Let's run it. Yeah, it got ran. Let's submit. Yeah, if you observe, there is a what I can say time milliseconds difference between the previous approach and this approach. Previous approach it took around 158 milliseconds, whereas this took 26 millions. Okay, milliseconds, I mean to say. Okay, that's all for this video. If you like my content and if you like the way I am teaching, don't forget to subscribe to my channel and don't forget to tap the bell icon so that you won't miss any notification whenever I upload any new video. And basically, I talk about the Java ecosystem and problem solving, and this is my hobby. So whenever I get some free time, I keep on uploading and I keep on sharing my knowledge with the fellow folks. Thanks a lot. Bye bye.